Assalamualaikum warahmatullahi wabarakatuh. And very good morning. So we are in the last unit. We have to cover at least some topics today for the test 3. Okay. So already we have started with the friction. I want to have the class without friction. Okay. So don't talk. Don't make me shout at you. So in friction, how will you classify friction? Static and dynamic is one classification. Static and kinetic. The other way, dry and wet friction. Okay, dry friction, friction between the two dry surfaces without any film of liquid between them. We call it as dry friction. Generally, our syllabus is confined to dry friction. Also, there is wet friction, where we have a thin film of lubrication. Okay. So wet friction, under wet friction we have journal bearings, all those components we have to take. So under this dry friction, we have started with static and kinetic friction. So if a body is resting on a surface, if you try to move the body, it will resist. Okay. So resistance is offered by the frictional force if the surface is not smooth. If there is a rough surface, the surface is not smooth, then there is a resistance for the movement of the body. So it will be in equilibrium. The applied force and friction will make the system at equilibrium. No motion at all. Equilibrium. Okay. So that friction which opposes the motion till the body starts moving, we call it as static friction. And as the body starts moving, that means the friction becomes less than the applied force. The body will be moving, but still there is some friction. Okay, so the friction offered as the body moves, as the body is moving. Okay, so that friction is called kinetic friction. Generally, kinetic friction will be less than static friction. As you remember the graph we have drawn, so the static friction will be proportional to the applied load. If you compare the normal, it will go proportionally, then it will come down, then it will become constant as the body moves. So until this point, we have static condition. After this, we have kinetic condition. Okay. So this proportionality, where your friction and the normal force. Okay. So the proportionality is given by your coefficient of friction. Okay, so we call this as F equals to mu times N. The equation of motion, equation of friction. The frictional force equals to coefficient of friction times the normal reaction acting on the body when it rests on the surface. Okay, so this F equals to mu times N. This mu can be mu S if it is static friction or mu K if it is kinetic friction. And this mu also equals to tan phi. This tan phi is called angle of friction. Okay. Tan phi is the angle of friction, angle made by the resultant with the normal. If you consider the block, okay, so the resultant force has some angle with the normal. The angle between the resultant force and the normal is called angle of friction. And this angle of friction is also equals to angle of repose. If you consider the body is moving on an inclined surface, so how much inclination we can have to keep the body in rest? So that limiting angle is called angle of repose. Okay. So if you tilt further, if the angle is increased further, the body will start moving. It will be impending in motion. So the limiting angle is the angle of repose. Angle of repose and angle of friction are same. Okay. For our simple body, if you consider. So these are all the concepts we have covered. We did some problem also for the blocks. Okay. So today we will see some more problems on simple contact bodies like a ladder. Okay. Suppose if you consider a ladder, consider a floor and the wall. This is having some ladder here. ladder will be having some weight, self weight. So if you consider the forces acting on the ladder with your resting force, resting floor and the wall, so you will have a normal reaction here at the surface, at the floor, as well as normal reaction at the wall. I say N, W and NF. Okay. And suppose if the ladder try to slip, as a slip, if it starts moving, it may move down like this, so you will have a friction force in this direction. Friction force on the floor. As it moves down like this, it will be, this end will be coming down, so your frictional force will be in this direction. I say frictional force on the wall. So if you draw the free body diagram for the ladder only, you will have this W, normal force at the floor, frictional force at the floor, then normal reaction at the wall, frictional reaction at the wall. Okay, so these are a system of forces in a ladder if you consider its free body diagram. When it is trying to slip, the slip begins now. Okay, as it starts slipping, then the action becomes kinetic. The coefficient of friction, you have to consider kinetic coefficient of friction. So this is the, suppose if the wall is given as smooth, so this is generally for a rough wall. Only if it is rough, we'll have friction. If it is a smooth wall, then there won't be any friction at all. There won't be any friction in the smooth wall. Okay, so that we have to be careful. Now we will consider one problem. We will have a similar ladder. So the self weight of the ladder is given, mass of the ladder is given as 15 kg. I will draw it again. So the length of the ladder, say this point is point A, this is point B. Length of the ladder is given. So that refers the standard data. The weight of the ladder is 15 Newton. Distance of the bottom end of the ladder from the wall is 8 meters. Length of the ladder is 10 meters. Okay, so this is the given setup. The length is given. Distance of the lower end of the ladder from the wall is given, and this wall is told as smooth wall. Wall is smooth. Okay, so that means no friction available at the wall. There won't be any friction at the wall. So this is the given setup. Now we have to find out whether the coefficient of friction between the floor and the ladder. Okay. We will find out the coefficient of friction. So how will you proceed? First we draw the free body diagram. So no frictional force and normal reaction as a smooth wall. If it is smooth wall, we will have the direct reaction that can be neglected. Okay, only your rough wall we will consider. We have to find out the frictional force offered, also the coefficient of friction. We have to find out the frictional force in the floor and also the mu s. The two data we have to find out. So we consider this. So this is 10. This is 8. So distance of the weight will be 4 meters. So this you can find out by using Pythagoras theorem. It will be 10 square minus 8 square. So it is 6 meters. Okay. So now you consider forces acting in y direction. Summation of, you use the equilibrium equation, we will sum up all the forces acting in the y direction. So we have only two forces, NF and W. I have assumed upward force as positive. Upward force, so this will be equal to 0, equilibrium condition. So NF will be equal to W, that is 15 Newton. Okay, so you are supposed to find out frictional force and coefficient of friction. Frictional force we don't know. Okay, also the coefficient of friction is not known. So we have to find out frictional force and coefficient of friction. So in order to find the coefficient of friction, we can find out only if we know all the unknowns. We have two unknowns now. Frictional force is also not known. NF is also not known. Okay, so in order to find, we are using two equations. The sigma F equation and sigma Fy equation and sigma Fx equation. Sigma Fx equation can be used now. There is only one force. Okay, so we cannot find out sigma Fx. So this cannot be used now. Okay, still it is unknown. Only one force. We cannot use this sigma Fx. So instead we go for third equation, that is sigma m equation. We have three equilibrium equations for a coplanar system: sigma fx, sigma fy, and sigma moment about any point of our interest. Okay, and moment about the perpendicular axis. If it is a coplanar system, of course. If it is a three-dimensional, we have six equations: sigma fx, fy, fz, and moment about the three axes. Okay, so we have three equations now. It is a coplanar system we consider. So we use sigma. I erase this. Moment about, I take this point, moment about P. Moment of all the forces about P. Okay, if I take about A, what will happen? These two will become 0. It's passing through the reference point, distance to the reference point will become 0. So it's better I take moment about B, moment about this point. Okay, this is point A and B. Moment about. If we take moment about B, so FF I say counterclockwise positive. Counterclockwise, some convention we have to follow. We are going to equate it to 0, so counterclockwise positive. So this force is in clockwise direction and W anti-clockwise. W is anti-clockwise direction. W into this distance is 4. Then FF minus or plus. FF into its perpendicular distance is 6 minus NF into 8 equals 0. So from this W is known, NF is known, FF can be found. So FF is obtained as 10. FF 10 meters. 10 Newton. FF 10 Newton. Correct? So using FF we can find out mu. FF equals to mu S times NF. we can find out mu as NF by FF, which will be 0.67. So I got mu also. Okay. So if this is a simple ladder problem, only the self weight is considered. Okay, you may have a problem with man standing on it, some load standing on it, like that also. So if you know the position, you will have more force system. That's all. You will have more forces acting on this ladder. So we have to resolve it sigma fx, sigma fy, and do it. Okay. Any doubt? Any doubt in this? Even if you consider NW, okay, NW is acting on, NW is no role. There is no need to find out FW. There is no friction force on the ball. So NW is negligible. That is why I said NW is not significant in this problem. In sigma fx equation, should be FF by FF by N 0.6. Well, the other problem, take down this next problem. A uniform ladder of length 9 meters. A uniform ladder of length 9 meters. Huh? No. Simple problem. You may get 12 marks like that, 10 or 12 marks. Uniform ladder of length 9 meters, weighing 17 Newton. Weighing 17 Newton is placed against a smooth vertical wall. Weighing 17. Uniform ladder of length 9 meters, weighing 17 Newton, placed against a smooth vertical wall with its lower end 3 meters from the wall. Lower end is 3 meters from the wall. The coefficient of friction between the ladder and the floor, mu, between the ladder and the floor is 0.3. Examine whether the ladder is in equilibrium or not. Examine whether the ladder is it in equilibrium or not. Examine whether the ladder is in equilibrium or not. So how will you proceed? To follow the same steps, we will find out the frictional force required for equilibrium. Okay, frictional is FF we can find. The FF is the frictional force which is required for equilibrium. Okay, then we will find out the actual frictional force using the given mu. First we find out NF, then FF, then mu is given. So mu times NF will give you the real frictional force existing in the maximum friction force we can have for the particular coefficient of friction. What is the friction force we have? If the frictional force required for equilibrium is less than what we get, then we can say it's in equilibrium. If it is more, it's not in equilibrium. Okay. So we have to follow 3 steps. Same procedure, similar problem only. Only thing is we have to check whether it is in equilibrium or not. So what we obtain from this equilibrium equations, that is the force, frictional force required for equilibrium. Okay. What we obtain by formula mu times NF, that is the frictional force we can have to the maximum for the actual mu. This distance is given as 3 meters, AB length 9 meters. AB length is 9 meters. You have same system of forces. So first we find out sigma F using the sigma F equation. NF minus W equal to 0. So what is NF? 17 Newton. The upward positive. Next, use counterclockwise moment of point B. Summation of all the moment about point B. So what is this distance? 3.5. W 17 into 1.5. So what is the value you get? From this equation, and if we find frictional force using mu, that is 0.3. NF, how much you got? 70. So this is 5.1. 5.1 is the maximum frictional force we can have for the given mu. Okay. So for equilibrium we need only 3. So it's already more than. So 5.1, 3 is less than 5.1. So we can say this is in equilibrium. Won't slip. It won't slip. Okay. So for the given frictional coefficient, maximum friction force we can have is 5.1. To keep it in equilibrium, we need only from the given data, for the given load, etc. It is only 3 Newton. So this is within the maximum frictional force we can have. So it will be in equilibrium. It won't slip. Okay. So the frictional force will be more. So if we get 5.1 as a second one. Take on the next problem. A uniform wall. Uniform ladder. A uniform ladder. Next problem. Uniform ladder 4 meters long. That's last loka. 4 meters long. Uniform ladder 4 meters long. Leans against the smooth wall. Leans against a smooth wall at an angle of 60 degrees. At an angle of 60 degrees. With horizontal. 60 degrees with horizontal. The weight of the ladder is 700 Newton. The weight of the ladder 700 Newton. When a person weighing 600 Newton, when a person weighing 600 Newton stands on the rug. RUNG, rung. The different steps. NG, rung. Stands on the rung. 1.2 meters. 1.2 meters from the bottom of the ladder. Stands on the rung. 1.2 meters from the bottom of the ladder. The ladder is about to slip. Find the mu. Find the coefficient of friction. Find the coefficient of friction between the ladder and the floor. Smooth against smooth wall. Uniform ladder 4 meters long, leans against a smooth wall at an angle of 60 degrees to horizontal. The weight of the ladder 700 Newton. When a person weighing 600 Newton stands on the rung At a distance of 1.2 meters from the bottom of the ladder, when the ladder is about to slip, find out mu. Find out the coefficient of friction. Okay? So we have an additional load, that's all. We have W and also an additional vertical load of the person who is standing at 1.2 meters from the. So we have to consider again the same sigma Fy, moment, sigma Fy, and the same procedure. We have to find out mu. Ff we find out mu. Find Ff, frictional force. Then normal force already we found by sigma Fy equation. Moment equation you can use for finding out frictional force. Then find out mu. Instead of giving the other distance, you are given the angle. That's all. Instead of giving the distance of the point A from the ball, the angle is given. So AB cos 60 will be AC. Resultant you have to sigma Fy is what is sigma m about P, moment about P. First find out sigma Fy. Consider similar to that upward percentage. Nf minus Wp சொல்லமா என்ன காம்பனன்ட் நான் உட்கார்ந்தே சொல்ல சிக்மா எம்பி என்னென்ன காம்பனன்ட் வரும் என்னென்ன ஈக்குவேஷன் సర్కిల్ కట్ ఉంటుంది. Moment about point B. We are taking moment of all the forces about point B. WB
plus W minus second.
So yes, we will level. Moment na. Hindu Muslim. Not excuse. Last
Into 1.2 sir.
Our Kadasi Kannadi. Very common area. Your class late up on Frictional and I have to do. What is it?
So WB into 1.2
WP into
1.2 force into vertical distance.
1.2 you get that.
1.2 distance.
No.
2.8.
It's not there. Seats were in line. Neglect.
2.8 sir.
WP into this distance you have to consider. Okay. Force into vertical distance, force into perpendicular distance from the point about which we take moment. So we have to consider WP into this up to this distance is 2. How much is this distance? You can find out. The point is E. So you have to consider each force and its perpendicular distance. Okay. So WP into EC. Then W into half of AC. Half of AC. Then frictional force BC into BC. So find out FF. FF we got as 302. 302.6. AE you can use angle. AD cos 60 will be AE. AD is 1.2. So AD cos 60 will be AE.
0.6 is
Mu 0.2. ಅಲ್ಲೇ Okay, so the value for mu is 0.23, 0.23. So for your test 3, test 3 we have half of unit 4 and half of unit 5. That is, in unit 4 up to impact of elastic bodies, impact. Okay, using sigma F equals to ma, you will get problem. Similarly, impulse. Impulse momentum equation, you have a problem. Then impact, collision of bodies. So until work energy, Newton's law, work energy, impulse momentum, impact. So 4 topics are there. Okay, in unit 4. Unit 5, friction of simple blocks, simple contact like blocks and ladder. You will have. Then 2 more topics I will just cover now. The rolling resistance and well friction. Okay. 4th chapter, first chapter, 4th chapter, F equals to ma, Newton's law, work energy principle, impulse momentum principle, impact. No, wait. Yo. Work energy, impulse and impact. So under friction, we have problems like simple contact, 2 blocks resting on an inclined plane. Okay, such a problem. And ladder, similar to ladder problem. Okay. Then we are going to see now 2 more topics: rolling resistance and well friction. Rolling resistance and well friction. But in the end semester exam, you have the remaining portion also. Okay, the vibration part, general body dynamics, GBD. So all this. Rigid body dynamics. So now we consider. Say another important concept in friction is rolling. Okay, we know wheel is one great invention in our history, so which made our world to move. Okay, but when the wheel rolls, there is a chance for friction again. By considering all the other loads, there is an axial friction, axial which moves inside the wheel. Okay, so that there will be friction between axial and the rotating wheel. Okay, similarly there may be a friction between wheel and the surface or road or track on which it moves. Okay, suppose if there is no friction, we will have only 2 loads, weight of the wheel and the normal reaction we get due to the weight. Okay, so theoretically, in ideal condition, we say that the wheel will rotate, wheel will move. It will be in dynamic equilibrium. It will be moving. Okay, if there is no friction at the track, if there is no other force, the wheel will move. But in reality, due to the weight of your wheel, the track may deform, or even if the track is very hard, the wheel may deform. There is a chance for deformation at the junction. So due to the deformation, by experimentally they found that the resultant force of the load is acting at some distance from the center, some distance B from the center at an inclination, resultant force. Okay. So if you draw the, if you take moment of all the forces about point A, so we get that P times the radius equals to W times B. So this PR equals to WB is the moment equation from which we can find out this P is called actually the rolling resistance, the distance between the line of action of W and the line of action of reaction force. Okay, so that is developed due to deformation. என்னப்பா சொன்ன லாஸ்ட்ல? What is rolling resistance? எதுக்கு பேசிட்டு இருக்கீங்க? Okay, so we have a deformation at the junction due to weight, so that the resultant of all the force, suppose if you want, so due to the deformation the wheel cannot move, we have to apply some force, then only the wheel will move. So we apply some force, so accordingly we get a reaction force. The reaction force is tilted at some angle, and the reaction force makes some distance from W. So this distance B is called rolling resistance. Okay, so the distance B is generally called as coefficient of rolling resistance. So this is about the rolling resistance. The rolling resistance is not dimensionless. It is a dimensional quantity. It will be in meters. Okay, since it is a distance, it is measured in meters or millimeters. So this value depends on many properties. It also depends on the material. For example, steel wheel on the steel rail, you will have it as 0.25. Suppose if it is on the rock, on the earth surface, it will be greater, it will be 0.5 something. Okay, so it depends on the material. The rolling resistance will be different, 0.25 millimeters. So rolling resistance is not a ratio, not a coefficient. Though we call it as coefficient of rolling resistance, that is actually the distance between the normal, between the line of action of W and the reaction, resultant force of the. Okay, so now we will see some point on belt friction. Mostly you won't get much problem on rolling resistance. We will get problems from belt friction only. So we will see about the belt friction. You know, there are many driving mechanisms or transmission systems. If you want to convey motion, there are different transmission systems. What are the different transmission systems we have? Gears, then belt, then shaft la transmit பண்ணனும் அதான் ரெண்டு shaft குள்ள we have to convey motion between two shafts. One may be the engine shaft. For example, in the automobile we have an engine shaft, also axle. Okay, so between the engine shaft and axle we have to convey the motion in a particular way. We have to transfer the motion in a particular way, transmit the motion in a particular way. It should be higher or it should be lesser. Okay, the speed may be increased or speed may be reduced. Speed may be at the 90-degree orientation. From the engine, we have to change the direction of rotation to 90 degrees. Okay, you have a propeller shaft. So the propeller shaft is connected to differential. Okay, so if you see the axle of the wheel and the propeller shaft, they are perpendicular to each other. So the transmission of motion takes place at 90 degrees angle. Okay, so like that we have to manipulate the motion from the source to the outlet, okay, from the appliance. So this manipulation is done by our driving mechanisms. So your belt drives are also one of the important drives, but in belt drives there is a problem of slip. So slip will occur when it is very smooth. So we have to study about the chances of slip and how the friction come into play in our belts. So it's a flexible material. So it has got many applications, like in the engine. Belts are used in different locations. We have timer belts. We have belt connecting the camshaft and the main shaft. Starter motor, there is a belt. AC motor, the compressor connected with belt. So belts are used in many locations in a single engine. There are many belts. Okay. So you have a belt drive shown like this for analytical purpose. We have a pulley. Belt, the transmission mechanism for belt is pulley. We call it pulley. So pulley and belt they form a pair. Okay, like gears, like cam and follower, they form a pair. Here pulley and belt, they form a pair. So in the belt there exists a tension. Okay, so the tension on the belt should be maintained to transmit motion. So belt and pulley, when they are the belt are kept in good tension, the transmission will be without slip. If the tension reduces, there will be a slip. Okay. So if you consider the belt, it is rotating, pulley is rotating like this. As it rotates, it will pull the belt from one side and releases it the other side. Pulling action. So as it rotates like this belt will be pulled. Okay, and it will be released on the other side. So the pulling side you will have maximum tension, and the other side you will have less tension. So the pulling side will be having additional tension, T plus del T. Additional tension exists in the pulling side, whereas in the releasing side you have only T. Okay. And at the contact you will have this point similar to your frictional block. You will have a normal reaction mu, normal reaction R, and it is related by the frictional coefficient between the belt and pulley material mu R. This is the frictional force. Frictional force acts in this direction because the pulley rotates in this direction. Opposite to the motion you will have a friction force. This mu R is the frictional force. Mu times R, if you see here, F equals to mu times N. Okay, instead of N, here we use R. Okay, or you can say mu times N. So this is N, this is mu times N. Okay, the angle made between pulley and the frictional force is the angle of friction. So suppose if you consider the equilibrium equation, sigma Fx and Fy, and resolve for the tension by considering single element and integrating for the whole belt, we finally get an expression relating two tensions. Okay, T1 and T2 are the two tensions. T1 is the maximum tension, T2 is the less tension, okay, at the slack side, that is equated by theta. Mu is the coefficient of friction, theta is called angle of lap. How much the belt is in contact with your pulley, angle of lap. Okay, so this equation is important in case of belt friction. So the belt friction depends on tension. Mu depends on tension between the two sides of the belt, slack side and tight side. So you take down the T1 plus T1 by T2 equals to mu theta, E power mu theta, and initial tension we keep in the belt is given as T1 plus T2 by. So the system of forces are resolved, and finally we get the expression for T1 and T2. That's all. This is natural logarithm, ln T1 by T2. Okay. We'll see one problem now. Here we have a machine which is connected to a drum by belt drive. A machine tool பேச மாட்டேன்னு சொன்னா ஒருத்தன். முன்னாடி வா அலாவுதீன். முன்னாடி வரையா வெளியே போறியா? வாக்குறுதியை காப்பாற்றணும்ல. அட்டி வாங்க. So we have a machine tool which is run by a pulley, okay, and pulley and motor. We have a larger pulley and smaller pulley. Two pulleys are there. The blue color one are pulleys. Okay. So the distance radius of the larger pulley is 8 meters. Here it is given 1 meters. The smaller one. This angle is given as 60 degrees. So it will be 180 plus 60. Total angle of lap you can see from here. Angle of lap for this pulley will be 180 plus 60, 240. Yeah. So we have to find out the mu is given, coefficient of friction 0.25 between the pulley and belt is given. Maximum allowable tension in the belt is 600 Newton. So maximum tension is given. T1 is given. 600 Newton is given. We have to find out the largest torque exerted by the belt on pulley. Largest torque exerted by the belt on pulley. Okay. So we can apply the T1 by T2 equation, find out the two tensions first. One tension is given, the other tension you have to find out. So in order to use that equation, we should know theta, angle of lap, and mu is given. Okay, so we should know angle of lap. So finding out the angle of lap, if you see at this figure, if you refer this figure, so this angle is 60. So the contact engagement starts here. So until here, you have the lap, both are in contact. Okay, so the total angle of contact will be 60 plus 180, 240. Whereas for here, 180 minus 60. 180 minus 60. 30 on both the sides. If you subtract, you will get 180 minus 60. So that will be 120. So angle of lap for both the pulleys can be obtained. There is also another formula. So if you consider both the pulleys, smaller pulley is having less angle of lap. So what will happen? Where the slip will be more, since there is only less contact in smaller pulley, slip will be more in B. Okay, in the smaller pulley. So we have to consider first the T1 by T2 equation for smaller pulley. T1 by T2 equation for the smaller pulley, and we find out the tension. So T1 is given as 600, mu is given. For smaller pulley, the angle of lap is instead of theta, beta is used. 2 pi theta. We have to convert it into radians. Okay. So by substituting in your equation, if it is sin theta, cos theta, okay, you will directly get radians. If you directly use angle, you won't get value in Newton or whatever. So in order to make it in SI system, we have to convert it into radians. Okay. So 120 degree is converted into radians, 2 pi by 3 radians. So T1 by T2 equals E4 mu theta. We get T2 as 355 Newton. Okay. We got the tension for slack side. Tight side is given. Maximum tension is given as 600 Newton. So convert theta into radians. You must remember that. You should not forget. Yeah. So after that, you have to find out the torque. You have to take moment of all the forces for pulley A. You got tension, the same tension will be existing at the pulley A also, at the same side. Okay. After finding the tensions, consider the system of forces, find out moment. E mu theta. That be theta. Here beta and put it. Substitute for it. That beta. General number theta is put it. In the problem it is mentioned as beta. Mu is coefficient of friction given as 0.25. 0 point between the belt and pulley. Friction between belt and pulley. It is given as 0 point. Starting same material. Only material will change. It is a material property. Next slide. So after finding T1, T2, we have to draw the free body diagram of pulley A now. Pulley A and take moment. So you have two tensions T1 and T2. Take moment of the forces about point A. Take moment of the forces about point A and equal it to 0 for equilibrium. You will get the torque. So T1 and T2 into 8. So T and proper distance is radius. The tension existing on the belt, yeah. So belt is perpendicularly placed, tangentially placed with the wheel, pulley. So T into its perpendicular distance is radius only. So that is why we have taken T1 into A plus T2 into A. Considering the direction, it becomes minus. Anti-clockwise positive. Okay? Go to the next problem. We have another problem. We have two drums. We have two drums to balance the rope, which is having a weight at the other end. We have to pull the rope so that it will be in equilibrium. So tension is given, pulling is given, and we assume it is in equilibrium. We have to find out the mass of the weight of the cylinder. Okay, that can be lifted by the car. So the mass we have to find out for the given T. Maximum tension is given as 500 Newton. Maximum tension 500 Newton. Angle of lab you can find out by inspection. Okay, and you have to find out other tension. This is a key. The pulley at the middle is free to rotate. It is in equilibrium, dynamic equilibrium, free to rotate. Okay. So tension at PA will be equal to AC. Both the tension will be same. PA will be equal to AC. That is why it is given as free to rotate. Okay. Why it is given as free to rotate? That means the tension that both the ropes which is passing through is same. If it is different, then there will be different in rotation. It is not free to rotate. Tight slack will be there. T will be tight. Tension and rope coming from each drum to the pulley on the same. There will be tight and slack side. The mass will be put actually pulley is given this side. So all the rope are trying to move towards right. All the rope are all the segment of the rope they are moving towards right. So you are pulling the rope at T. So if you pull it, all the rope segment is moving towards right only. So it was left only. So what happens? The rotation you have to consider. The pulling side is this side, opposite will be sliding side. So you have pulling side here. Pulling side for this rope. So pulling side will be here. Okay. So the other side will be the slack side. Other side will be the slack side. All the ropes are pulled here. In order to lift the weight, lift the cylinder. So W causes the cord to move counterclockwise directly over the drum. So your T1 is 500 Newton given. Okay, the force applied. So the total angle 180 minus 45. 180 minus 45 is 130. 180 is the half circle of the angle of the drum. And 45 given. Okay. So you will get T1 as 500 and T2 you can find out using the formula as 277.4. Okay. So now we Gavani, இது ரெண்டு கவனிக்கலாமா? So we have two drums. So we consider the first drum, draw the free body diagram of the first drum. Since pulling is given at the left side, so that is considered as the maximum tension T1. So using the equation and angle, we find T2. We have found T2. Then consider the second drum. See, okay, middle is not important. It is an idle pulley, free pulley. So the second drum, again the angle will be 180 minus 45, 135. Here this load is W. This is to T1. T1, the what we found earlier, T2, right? T2. So we use the same equation, find out W and find out T. We have contact from here only. So this angle is 180 minus 45, this is 135. Up to this. This is 180. So this angle will be 180 minus 45. So these two are opposite angles. Okay. The same way you have to do it for the other from us. I have the assignments ready. So when you are going to submit?